What is the net force on the square coil? Okay, there is a current carrying conductor and there is a square coil. Now you will think that, sir, this is a question based on EMT. But my friend, EMT is a prerequisite for electrical machine. EMT is the prerequisite for electrical machine. Arvind, you are asking, is electrical the toughest? Don't you think after studying machine that electrical is the toughest? Don't you think that the other branch can't cope up with electrical machines? So now, try this everybody. Come on, come on, come on. I want quick answers. I want quick answers from everybody. Show me the answer. What is the answer? A, B, C, D. I am not telling you it can be MSQ, MCQ. I won't tell you. You have to decide. You have to decide. I see that Mayank has already figured out the answer. What is the answer? Everybody contribute guys. Find the answer. Tell me what should be the answer. जल्दी जल्दी आंसर निकालो मेरे भाई. मयंक, मैंने सुन लिया मेरे भाई तुम्हारा आंसर. बार बार क्यों लिख रहे हो? Let us see. So guys, in this problem, what I'll do is I'll divide this loop into 4 parts like A, B, C, D. Okay, I'll divide it into 4 parts. Now, I'll find out the force on each and every part. Now, let me take first of all this AB and this CD. Now, if we take a small section, in both the segment, dx, correct? Now, if this is at x distance from the wire, what is the magnetic flux density of a current carrying conductor? It is mu naught I by 2 pi x. Okay, so magnetic flux density is identical for the upper and the lower part because both are at a distance x. Now, when you talk about the force, my friend, the force is this. Now you will say, sir, what is this dx vector? Dx vector is directed in current direction. Remember this. Dx vector is always directed in current direction. Now, how do I solve such kind of question? I solve them by drawing x, y and z axes. Okay. Now here the current dx vector will be in ay. Here the dx vector in the current direction will be minus ay. Why ay? Because it is to the right. That is why ay. This one is to the left, minus ay. So that is why ay and minus ay. Now see this. If you see this, this current is going upward, so the magnetic field will go inwards. It will go inwards. The magnetic field will be like this. It will go inwards here, it will come outwards here. So the magnetic field here is into the plane of paper. Okay, the magnetic field is into the plane of the paper. The magnetic field is into the plane of the paper. Into the plane means that the magnetic field is minus ax cap. Into means outwards is x, so inwards minus x. So if it is minus x, okay, then ay cross minus ax. Ay cross minus ax What is it? AY cross minus AX. Quickly everybody tell me. What is AY cross minus AX? AY cross minus AX is AZ. AZ. So here my friend the force will be upward. What about minus AY cross minus AX? Minus AZ. So if you see my friend, the force on the section AB is upward, the force on the section CD is downwards. So force on AB is equal and opposite to force on CD. Okay, that means the force on AB and CD will cancel each other. They are equal and opposite. Always remember when you are dealing with the EMT problems, if you are doing them in the coordinate system, rather than going by right hand rule, Fleming, left hand rule, nothing. Just go by coordinate system, your accuracy will increase. Your accuracy will increase. Khushi, what is not proper about the explanation? You are saying please repeat again and properly. What do you mean by properly? Okay, now one more thing that you should know is that if two conductor carry current, in same direction, then they experience attractive force. Now, if two conductor carry current in opposite direction, then they experience repulsive force. Okay, my friend, they experience repulsive force. Now see, this current is upward, this is also upward, so this one will be attractive, but this is downward, so this force will be repulsive. This force will be repulsive. Okay. So now, when two currents flow in the same direction, then the force is attractive. When the two currents are in opposite direction, the force is repulsive. Now you see, my friend, the force on AD and the force on BC is in opposite direction. The force on AD and force on BC is in opposite direction. FAD and FBC are opposite. Now when I want to find force on AD, I need flux density at AD. I need flux density at AD. That will be mu naught I by 2 pi. What is the distance? 2 centimeter. And what about the force? That is mu naught I B into current. What is the current? Let me say I dash into length. What is the length of AD? What is this length? This length is 15 centimeter. So what I have done is, I have written the force as ILB. I have written the force as ILB. First I have figured out the flux density. Then I have multiplied it by current into length. Current into length. Now, similarly, you can calculate the flux density at BC. For flux density at BC, what is the distance? The distance, my friend, is 12 centimeter. So mu naught I, see, the way I attempt a problem, I minimize the use of calculator. I minimize the use of calculator. Okay, my friends. Now, we have the two forces, force on AD and force on BC. Now, once we have the two forces, both are in opposite direction. So, I'll subtract both to find the net force. So, let me take the common part common. Okay. This is the net force. This is the net force if I substitute the values. If I substitute the value 4 pi into 10 to the power minus 7 by 2 pi. What are the currents? 2 ampere. And what is the current in this case? 1 ampere. 2 ampere and 1 ampere. Okay. Then 0.15. Then 0.1. Then basically 0.12 minus 0.02. Or you can say this can be 6 by 0.12, 5 by 0.12. Simply 5 by 0.12. So what is the answer are we getting? What is the answer are we getting? Okay, tell me what is the answer are we getting? First of all, it will be towards because f of AD is basically greater than f of BC. Why force on AD is greater? Why force on AD is greater? Because the distance is less, so magnetic flux density is high. The distance is less, magnetic flux density is high. That is why force on AD is high. If the force on AD is high, the force will be towards the wire. The force will be towards the wire. Answer will be A, moving towards the wire. Answer will be A, moving towards the wire. Now let me quickly recap this question. First of all, what I proved is the force on AB and the force on CD. One is vertically upward, one is vertically downward. Both are equal and opposite. So that is why their net force will be 0. But in case of AD and BC, the force was opposite but not equal. Why not equal? Because their distance from the wire was different. If their distance from the wire is different, their forces will be unequal because the magnetic field is unequal. Moving on. Try the next one. Again based on the same concept but conceptual. Again I am not telling whether it is MCQ or MSQ, that you have to figure out. I am not telling this. Try this. Two long wires are hanging freely. They are first joined in parallel, then in series, and then are connected with a battery. In both the cases, which type of force acts between the two wires? It is saying that two long wires are hanging freely. They are first connected in parallel, then in series. Let me see. Okay, now I believe it must be visible. Okay, they are first connected in parallel, then in series. In both cases, what type of force acts between them? Okay, my friend. Now, let me show you. It is saying that both wires, see, both wires are hanging freely. Like this. Okay. These wires are hanging freely. Now it is saying the two wires are once connected in series and once connected in parallel. We need to know the nature of force between them. So let me show you. First, let me show you the series connection. How is the series connection? See, this is the series connection. This is the series connection. So how the current will flow? Current will leave the positive terminal of the battery and come back to the negative terminal. Will leave the positive terminal, come back to the negative terminal. So both are carrying current in opposite direction. Both are carrying current in opposite direction. So it is repulsive. Repulsive. Now, when both are connected in parallel, let me show you how they are connected in parallel. When both are connected in parallel and they are connected to a battery, don't think that we are shorting the battery. These are the wires, they will have resistance. Then the current from the battery will be like this, which will get divided into two parts, I1 and I2. Both are carrying current in same direction, hence attractive. Attractive. That means repulsive in series, attractive in parallel. Repulsive in series, attractive in parallel. So repulsive in series, attractive in parallel. So the answer would be A and C. A and C. That is your MSQ type of question. Okay guys, MSQ. Now, try the next one. Try the next one everybody. A straight wire of length L. Let me bring it down a bit. Okay. Now, a straight wire of length L is bent into a semicircle. It is moved in a uniform magnetic field V with speed V with diameter perpendicular to the field. We need to find the induced EMF between the ends of the wire. Induced EMF between the ends of the wire. Okay. What is the induced EMF? When the straight wire of length L is bent in the form of a semicircle. Okay, so let me show you this in a diagram. How we are taking it. See, it is saying that the wire is bent into a form of semicircle. It is moved in a uniform magnetic field with speed and diameter perpendicular to the field. So what I am saying is, these are the axes. Suppose this is a semicircular wire. This is a semicircular wire. Now assume that the magnetic field is like this. This is magnetic field. Now the magnetic field is perpendicular to the diameter of the wire, and the velocity let us take in this direction. So velocity is also perpendicular. If we mark it as x, y and z, then velocity is in AZ cap, magnetic field minus AX cap, and the diameter. That is what it is saying, that the velocity and the diameter, are both perpendicular to the magnetic field. The velocity and the diameter are both perpendicular to the magnetic field. That is what it is saying. Now it is asking the EMF between the ends of the wire. EMF between the ends of the wire. Now in such a case, my friend, what you have to do? The easiest method is taking the projection of the ring. So the projection of this ring or semicircular wire will be this. This will be the projection. Okay. This is what? Projection. Now in this case, my friend, the EMF induced is basically motional EMF. EMF induced is basically motional EMF. What is this motional EMF? It is given by V cross B dot dl. What is the velocity? The velocity is V AZ cap cross B minus AX cap dot dl AY cap. Now AZ cross minus AX is what? How much? AZ cross minus AX is minus AY. Minus AY dot AY is minus 1. Okay, the length will be equal to diameter. Now the total length of the wire is pi r or pi d by 2. So diameter is 2l by pi. If the diameter is 2l by pi, my friend, then this EMF will be, now you will say, sir, why you have ignored minus sign? Why I have ignored minus sign? The minus sign just tells us the polarity of EMF. Minus sign just tells us the polarity of EMF and nothing else. So the answer would be D. Okay. Now Rahul is asking, are we solving EMFT? Rahul, my friend, EMFT is a prerequisite for machine. So today we are doing the things that are required before we go to machines. Okay. And Pawan, your question, the question that you are asking, what is the difference between induced EMF and motional? My friend, you need to study the entire EMT again.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.